Okay, this is today's lesson. Today is Thursday, and the date is March 28, 2013. And what we're doing is we're starting something new with heterogeneous equilibria. And these equilibria are equilibria where all states are the same, being called homogeneous, and at least one state is different than the others, meaning heterogeneous. And the example that I got here is from last night's homework. And so when we have a reaction like this one up here, we see that we have a G and a G. So both states are the same. Both have the same state is what I should have said. And because they both have the same state, we call that a homogeneous equilibrium.
So
now,
there's two G's, it's almost...
well, if they're both the same, whether there's 2, 3, or 4. Okay, down here, there's 1, 2, 3.
So that's hetero?
No, why would it be hetero? Aren't they all the same? They're all G, aren't they?
Oh, I thought if it's a 2, it's homo, it's hetero.
No, I'm glad I did more than one example then. Okay, and we look down here, and we see G, 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 G. Now here it's 4 G's. So what would you say this is? Hetero or homo? Uh-huh.
Homo.
Yes, absolutely, because they're all the same.
Not bad.
So you got the idea. Now, what I did is I modified this one to be an L, and because that's an L, Brian, what do we have?
Homo. Oh, hetero.
Got it. Okay, hetero. So the other thing is we got to remember reactants and products. Let's go back to yesterday's one of yesterday's slides, and you might remember this guy. I could move these around, which is very nice because now we can see that in this particular reaction, the way I have it set, I have 3 reactants and only 1 product.
Oh, this was the lesson from yesterday when you
Yes.
went to D, right?
Mm-hmm. And what I'm trying to show here is A, B, C, and D just mean the first, second, and third, and fourth thing as we are going across the reaction. So here, because we have 1, 2, 3 reactants, we have A, B, and C all on the left side. And we only have D on the right side. For the same reason, going back to the original way that I had this, for this reaction, A and B are on the left and C and D are on the right. But I could also have this situation where I have A only on the left side, and so I only have 1 reactant. So B now has become a product instead of a reactant because there was only 1 reactant. So basically you're just going across as you look at the reaction, left to right, and calling them A, B, C, D. If I had 3 products, then I'd have A, B, C, D, E. And if there was only 1 reactant and I had 4 products, the A, B, C, D would mean that we now have 4 products. And so these guys are strictly going from left to right. And let's go on back now and continue what we were doing. Okay, we saw this guy. Whoops, let's go back here. And now, solids and pure liquids are replaced by the value 1 in the equilibrium expressions. And these guys are examples of that. And I'm going to go in here and give you good examples of how this applies. So it always helps to have a solid example of how things are actually going to be given to you. And in this particular situation, your problems, okay, 3 and 4, you're going to plug in values, which we haven't done before. And we're also going to have to identify the hetero and homo and be able to get rid of things that are solids or liquids. So let's go by the cards.
Is that the D when you remove the D?
When I remove the D? What do you mean?
The formula.
Okay, in this formula, how many letters do I have? In this particular reaction, that is.
Which one's the D?
And
4.
just one second. In this reaction, we have only two things. So in the stylized equation, this would be A and this would be B. And A would be our
That's
only reactant.
C?
And no, this is B.
No, the other one next to it.
This is A.
And the other one?
That's not part of an equation.
Oh, it's
This
not?
is a given.
No, the other one next. Go that way? No, this
To
way.
the right,
Yeah, that one next to the H. G-O? Or what is that?
this is S. This is carbon 10.
Yeah, is that the A?
That's, no. Carbon 10 H8. C10H8 is one molecule.
Oh, that's one thing.
One molecule.
Yeah.
Okay, so this is A. That's why, okay, I see where you were getting.
Yeah, I thought it was two different.
Right, there's no A, B, C, D here. And the way you know for sure is there's no plus right here.
Oh.
You don't see a plus in there, do you?
Oh, so it's not like A, B, C, D,
No. This is one particular kind of molecule. Okay? And it has 10 carbons and 8 hydrogens. And this is the same guy, but now this dude is in the solid state and this guy is in the gaseous. Now, according to what we did yesterday, we would write the K equilibrium just like this, wouldn't we? Okay, that's the way I want you to do it tonight, even if you have a solid or a liquid that is part of the balanced equation, which would be represented by these two guys up here. Okay, so going down here now, if we notice that reactants are on the bottom, aren't they? In K equilibrium? Okay, so that means that this guy is a reactant and he's the one that's down here. Okay, so let's rewrite this now. C10H8 with the brackets. Now, what's going to be on the bottom? What do you think, Paul?
Me?
Yeah.
C times.
Now, don't forget this.
Oh,
What's going to be on the bottom?
1.
Very good, Paul. You went right to it. Excellent. Okay? That's what we mean by making the value 1. Yeah. Absolutely must, or I will not give you credit for the homework problem. I want you to do this just like you did last night, and then I want you to get this, and I'm going to show you why it's so important. The 1 has to be on the bottom because this guy was a solid, and solids and liquids. What? No, you wouldn't have to do it later, but you put the 1 there because I want you to see that, and you'll understand why when I give you the next example. Okay?
When is this video going to be uploaded?
Now we're not, yes. And now what we're going to do is we're going to substitute in the actual value for the given. Okay, the given here was giving us 0.15 molar of this C10H8. So, what is the top part of this side going to look like now, Ciara? Top part of this is going to be what? We plug in the given. What's going to be on top and bottom now? What's going to be on the top? Now we're plugging in the actual value of the molarity. Okay, well, say it.
0. I know it.
For once, she does not have something.
Yeah, she surprised me.
0.
Shh. Come on, Sierra, you can do this. You don't look in your book, it's not in the book. It's all on the board. What's the given value for the molarity?
0.15
There we go.
Yeah.
0.15. Now you can leave out the molar, the big M. Yes.
CRN.
What? Get this? Are you asking about this guy? Okay, this guy came from the given. always has to be given. You can't just make it up. Okay, they have to give it to you. This is, yeah, the molarity. Now when you put it in here, you're not going to put the big M there because you don't need it anymore. The equilibrium constant is just a number. Okay, and Ciara, what's on the bottom? Okay, so we can rewrite this, can't we? And it's going to be 0.15, and that's your final answer. Now you can get rid of the 1, no problem. Now I'll show you why you absolutely must, for homework credit, put in that 1, depending on where it is, doesn't matter. You still have to put it in. I'm going to do a second problem with the same two reactant, the same reactant and product, only we're going to switch them. Yes.
How do you get the 0.15?
0.115. That, or 0.15. That 0.15 is a given. Okay, the given is right here. Okay, that's where that came from. Now, yes.
Okay, so the given is always
No. No, because what if you have 4 different items? 2 reactants, 2 products. No, the givens have to be plugged in and the numbers have to be crunched. Right?
Crunch roll.
Yeah, the crunch roll. Okay, let's look at this.
Well, what's the crunch?
Don't worry about
Oh, I
that.
thought it's not
All right.
sushi.
C10, H8,
Mhm.
and this would be gas now. And by the way, you can do this with any equation, but you're going to change the equilibrium constant when you do. C10H8, and this guy's going to be the solid. Now the plot thickens a little bit here. Watch what this means. What's the case of equilibrium now? Whoops.
Okay,
No,
so
let's
we
get
got
rid of
here
this.
vibration.
Case of EQ is now equal to, and who are we going to have do this? Let's have Mario do this one. Okay, Mario, what's on the top? C10, H8, and what's on the bottom? Yes, it is. C10, H8. Now, folks, who's on the bottom? Who's on the bottom? The gas. Okay, the solid now is on the top. Now, what do we have to do with all solids? What do solids have to do?
1.
1. Solids or liquids, you have to substitute a 1. And now we have the C10, oops, C10H8 is on the bottom in its little brackets. And now we're going to substitute the value, which was what? 0.15. Okay, so we have 1 over 0.15, and that's equal to 0.677, whoops, 667, because it's a repeating decimal. That's the answer. Now, do you understand why it's so important to always put that 1 in?
Yeah.
Because if you did not do that as a habit, you would be tempted to say that the answer was 0.15, wouldn't you?
The answer is 6.667.
Oh, it's 6.667? Have my decimal? Oh, yeah, because there's a decimal there. Yep. Okay. Thank you. 6.67. Yeah, because if it were 15, if it were 1.5, it would be, yeah. Because in the equation, the way I wrote it this time, which is different than last time, isn't it? Here's the last time. Notice the solid is on the left here. The left always goes on the bottom. Reactants are always on the bottom. Solids don't go anywhere. They go wherever they belong, and everything that's on the left belongs on the bottom. Everything that's on the right belongs on the top. That's why we knew that this guy, even though he's the same formula as the guy above, we knew that he was a solid because the solid was on the left side of the equation. Now down here, the solid is on the right side of the equation, and so he's the one that's down here. Whoops, I'm sorry. The gas was on the left. I'm sorry. What did I do? Yeah, that's what I did. Okay. Yeah, the gas is on the bottom, and the solid here, which has to become a 1, was on the right-hand side. Solids become 1, as do liquids, pure liquids. Yeah. Okay, and that's one of the things that's always common with heterogeneous. Solid or a liquid in there somewhere. Okay, does that make sense now? Monster mass. Okay, here we go. Let's go on and let's fill in this guy. Let's say that the H2 concentration is equal to 0.3, or no, just 3. H2 concentration is 3. CH4 concentration is equal to 5. And water concentration is equal to 7. Now let's make it 4. Now here's the equilibrium constant. This guy's a liquid. What do we do with him? Okay, so we have CH4 on top. What's the exponent? This person blew it. What's the exponent for CH4? Oh, there's none. Okay, and water, there's none. Those guys are on top because they're the right side of the equation, correct? Okay, the reactants are on the bottom, so we have H2 down here, cubed. And we have the CO as 1. Are we good? All right. So now all we have to do is plug in the numbers. CH4 is 5. And now we don't need to worry about the brackets. We can just write parentheses. All right. And the water is 4. And the hydrogen is 5. Whoops, I'm sorry, 3. And that baby's cubed. And then we solve. So order of operations, you always want to take care of your exponents first. So 3 times 3 is 9 times 3 is 27. So this is equal to 20 over 27. And then you want to go ahead and solve it for whatever that number is. It'll be point something, yeah? 0.7407. Actually, because we only have one sig fig, so that'll work. Are we good? Now let's do this guy again. Same kind of deal. This time we had a really simple equation, and this was NO2 is going back and forth with N2O4, and they're both gases. So this isn't a heterogeneous, is it? Homo, there's no liquid, there's no gas. So we have the reactants on the bottom, the NO2. We have the product on the top. Let's go on. And on the top we have N2O4. Now we don't have to put a 1 in for any of them, so all we have to do is substitute the values. So the case of equilibrium is the N2O4 is on the top. So that's 3 over 5. Piece of cake. 0.75? We'll get the stamps. I can stamp you before you go if you want to come up. And so there we are for that little screen, and that pretty much takes care of it, huh? Okay. Whoops, back here. And now let's plug this guy in. Okay, same deal again. We're going to just plug in the numbers. So the hydrogen is a 5, the sulfur is a 3, and the H2S, there's nothing squared, so that's easy. And we got 15 over 9, which is equal to 1 point something. Anybody have that?
Here you go.
That. So, as you see, after we do our calculation, that gives you your final answer. And I think you should be pretty good to go for tonight's homework.